Okay, so good morning to everyone. Now, in the last class, we have started discussing of the two-level organizations in the memory. So, in this two-level organization, we see that there are the two types. One is the independent organization. So, the independent organization we have already discussed. Now, we will see the hierarchical organization in the two-level organization. Memory organization, we will see the hierarchical organization. So what is this? Basically, there will be the CPU. This is the CPU. The CPU will be present, and then CPU will be connected with level 1 L1 device, and this level 1 device will be connected to L2 device. Now that means what? This L1 device will have the least access time, because this L1 device is directly connected with the CPU. So this L1 device access time will be less because it is directly connected with the CPU. Whether this L2 device access time will be more than the L1, will be the more than the L1. So this access time, this L1 device access time will be less. This L2 level of memory, this level of memory's access time will be more than the L1. And there will be what? This L1 has the speed much more, because whichever the access time will be less, that speed will be much more. And the L1 has the least storage, because this L1 storage is less compared to the L2 device. So if we remember the hierarchy order, that whichever access time and the speed is much more, that has the less storage capacity, whereas that has the level of the memory which has the maximum storage has access time much more, and also our speed is also required much more. Speed is what? The speed is very much, and access time is what? Because if speed is high, then the access time is low. If the speed is low, then the access time will be much more. So this way, this L2 device, speed is less compared to the L1 device or the L1 level of memory. This level of memory, L2 is what? L2 speed is less compared to the L1, and that's why L1's access time is much more compared to the L2. But L1 has the least storage, whereas L2 has the maximum storage, because its storage capacity is maximum. Now let's say the CPU wants to find the data, that particular data CPU wants to find. Now, in the independent organization, we have seen that the searching will be done in parallelly. That CPU in that particular time, that the data that is checking in the L1, and that particular time CPU also checking that particular data in the L2. So in a single line time, or this that parallelly there will be checked that the data is present in L1 and L2. In whichever level it is present, that time it will be checked parallelly. But here you see, if CPU wants to search some data, then first it will search in the L1. Now after, if that data it didn't find in the L1, then it will start searching in the L2. But in that case, parallelly the searching is started in L1 and L2. So parallelly the searching is done here. But in this case, for the hierarchical organization, we have seen that the searching is what? That the searching will be, if CPU wants to find some data, then first search will be on the L1. This L1, the search will occur, and if the data is not found in this L1, in that case, the data will be present in the L2, because here two levels we have used. So if any data we didn't find in the L1, that particular data should be found in the L2, because L2 has the capacity or the storage much more, and we are saying that it is the 100%, the maximum capacity is present. The data that is not present in L1 will surely present in the L2. We are considering that, we are saying that. So let's say first CPU searching started, then the data is searched in the L1. So if the data that it is searching, so what will be the T average? So the T average time will be what? So from this we will prepare the expression. So if the data that is searching by the CPU find in the L1, then that means what? We call it as a hit. The hit has occurred. So that's why what will be the hit ratio? The hit ratio will be H1. So the hit ratio will be H1. Now, finding this particular data in the L1, how much time it takes? It takes, we are considering the access time of L1 as T1. So the total it will be H1 T1 plus. Now let's say the data that we didn't find in the L1, then where this will go? Then the searching will be going to the L2. Now, then what will happen? We are considering the data that is not present in L1. So that means if the data is present, we are saying that the heat has been occurred. But if the data is not present, then what will happen? We will consider it as miss. So here in the second case that the data we didn't find in the L1. So that means what happened? The miss has been occurred. We are considering the miss has been occurred. So what will be the miss concept? So if heat is what? H1, then miss will be what? If you remember in the probability, what will happen? If the heat is occurred, then miss will be what? 1 minus H1. Because the two concept in the probability also, you have seen that head and tail, the probability of the head and tail, considering the case total as the 1. We are considered that like that. So if the data is not found in the L1, that means what happened? That means the miss has been occurred. So miss has been occurred means what? That the miss concept will be 1 minus H1. So this will be miss 1 minus H1. Now what will be the searching time? Now here you see the data that is not found in the L1. But for that reason also, CPU has to check in the L1. After checking L1, it says that the data is not found. So that means that access time should be considered, because CPU in that parallel case, the CPU has checked L1 and in parallel the CPU has to check L2. So in that case, we are not considering that the if data is not found, then that means we are not considering this particular concept. But here, first you have to do what? First you have to search in L1. Then after searching the L1, if you not found, then you can say, yes, it is not found in the L1. So searching that L1, how much time it takes? For searching that L1, it takes T1 time. So T1 time will be considered. Now the data is not found in the L1, the data is found in the L2. So that means what will be the access time into the L2? The access time into the L2 will be T2. So that's how the expression can be made. It is clear to everyone that how I have performed this expression.
Yes,
It
sir.
is clear. It is clear.
Yes, sir.
Okay. So that's how the hierarchical organization is. So this is what, this is a two-level memory organization. So this will be what? This is the two-level memory organization. Now we will move to the three-level memory organization. Same as that for the three-level memory organization. In that case, we are using two levels. Here we are in this three-level memory organization. We are using three levels, and but the types are same. There also it is independent organization present, and in the other case there is the hierarchical organization present. So these are same. It is not changed. So for the three-level memory organization, now let's say this L1, L2, L3. We are considering this L1, L2 and L3 can be cache, RAM or hard disk. It can be like if we see in the pyramid, then that means what? The topmost, because we are considering that L1 device will have the maximum access time. So if we consider it as the maximum access time, then that means which is considering, we are considering it as the cache. Then L2, this L2 has access time more than the L2, L1, but less than the L3, less than the L3, but more than the L1. So which type is what? Then let's say L2, we consider it as the our RAM, and L3, this is the between among these three device, among these three device, if we consider this L3 has the maximum storage, but access time is what? Access time is maximum for this device. So that's why what happened? We are considering this L3, let's say, as the hard disk. Because if we take L1 as the cache, L2 as the RAM, then L3 we have to prepare that cache and RAM. Among this, the next is that we will able to consider that has the maximum storage as the hard disk. Let's say we consider it as a hard disk. Or it may happen that L1 and L2 is the two different cache, and this L3 is what? This L3 is a, let's say, a RAM. Like this you can consider. But you have to, whatever device you consider, you have to remember one thing, that the first L1 will be what? L1 access time will be less, storage is less, and its speed is more. But L2 will be what? L2's access time is more than the L1, and it has storage more than the L1, but its speed is less than the L1. And the L3 is what? Among these three, L3 has the maximum storage, but it has the speed less than L1 and L2, and its access time is what? Its access time is also more than the L1 and L2. So these things you should keep in mind. Now, if we have three levels of memory, then how we will organize this three levels? Now, computer organization, this is the concept of the computer organization, that the computer organization basic principle is to how we can connect the device. So the devices which we have present, these devices or the resource which how we can connect it, it looks over that. Computer organization part looks over that. But if you go to the computer architecture part, that is, we have seen the pipelining concept, we have seen the delays, then the data hazards, like this we have seen. If you observe, the computer architecture part basically talks about the performance, the optimization related thing. That means, let's say this, if we already seen in the pipeline that if we follow this, then there will be our increase, the speed will be increased. So like these things, that means the computer organization part is related to the performance optimization, like this. But computer organization part is what? This is computer organization part looks over how we can connect the device. So that is what we have mentioned in this also, that how the devices are to be connected. And Access time of L1 is least because its speed is high compared to the L2 and L3. Now we will prepare the average, the T average, which we have seen for the 2-level organization. Here also for this 3-level organization, independent organization T average time, we will consider that how it can be made. Now if you see, the T average time will be what? If the data that is CPU is searching, so searching will be done parallelly. In the particular time, the searching will be L1. In that particular time, the searching will be on L2. And in this particular time, the searching will be L3. So all the devices, all the devices, the searching will be done parallelly. So parallelly in a single time, this will be searched. So a particular time, this will be searched. So if let's say the data which we are searching, that data is what? That data is present in L1. Then what will be the thing? If the data is present in the L1, then heat ratio will be what? The heat ratio, because we are considering that if, because it is what? Why we are considering L1 always? That the L1, in the L1 device, the data is present. We consider it as a heat because we know that the L3, in the L3, all the data should be present. We know because it has the maximum storage. It has the maximum storage. So whether you didn't find the data in L1 or L2, you will surely find that data in the L3 because it has what? It has a maximum storage. So it is not the thing that we want that the data should be present in L3. Because why you didn't want to know that the data, we didn't use that the data that is present in the L3? Because we want our data should be present in the L1. Because if the data is present in the L1, to accessing that particular data, we have to require less access time. So that's why we always prefer that because we know that L1 device has the least storage, but access time is what? Access time is very less. And that's why the speed is what? Its speed is very much. That's why the access time is less. So we always prefer that the data that is present should be present in the L1. Because if the data should be present in the L1, then access time will be less, so we can easily access it. So we always prefer that the data should be present in the L1. So we always prefer that. And that's why we are saying that if the data is present in the L1, consider it as a heat. Consider it as a heat. So that's why that's the case that we always prefer and always say that the data if found in the L1 will be the heat. So in this, what happened in the L1? Let's say the data find in the L1, then the heat will be occurred. So it will be H1, and the average access time, the access time will be T1. So the access time will be T1 plus. Then we have to see the next case. If the data is not present in the L1. Now, if the data is not present in the L1, that means what? Miss has been occurred. Now, if the miss is occurred, so first we have to take the miss. So what is the miss? 1 minus H1. That is the miss concept because the data we didn't find in the L1. So that's why this is the missed concept. Now let's say the data we searching is found in the L2. So what will be happen? The heat ratio of the L2 is what? H2. So 1 minus H1, then H2, because this is the second case that the data that is found in the L2. So if the data is found in the L2, then that means what? The data we didn't find in the L1. So that's why we have used the first, the miss concept. And then after that, we have used the heat, because if the data is found in the L2, then that means the heat has been occurred. So we consider the H2. And the access time will be what? The access time will be T2. So this is the second case. Now, what will be the third case? Can anyone try? What will be the third case?
1 minus
Anyone?
H1, 1 minus H2,
Hmm.
H3, P3.
You have said right, but the thing is what? 1 minus H1, it will be 1 minus H1, then 1 minus H2, and here we will not consider the H3. Yes, it is right that we have to consider it, but we will not consider the H3 because we know that if the data we didn't find in L1 and L2, it is sure that it will be found in the L3. We know because the storage space of L3 is much more. So there is no need to use the heat ratio of the L3 because the data, if it is not found in L1, if it is not found in L2, we will surely find 100% sure that the data we will find in the L3. So there it is not we have to consider that. We didn't require to consider the H3 for this reason. So we will do 1 minus H1, 1 minus H2 and P3. So this will be the third case because yes, you can say that H3 why we not consider because for this reason we are not considering because we know that the data should be present in the L3. The data that will be present in the L3 because if the data is not present in the L3, then the data we are searching, that data is not present in any of these levels. Then why we will use that? So that's why we will not consider the H3 because we know and this H3 the heat will be occurred. The heat we will find 100% sure we will find that. So that's why we will not consider the H3. So it will be what? 1 minus H1, 1 minus H2, T3. So this will be the hierarchical independent organization T average time. Like this, we'll prepare the average time of the independent organization. Now, another thing is what? Another type is our hierarchical organization. So what will be the hierarchical organization? T average time. So hierarchical organization, first we will see the picture. So this is what the hierarchical organization concept, that the CPU will be there. In this CPU, it will be connected with the L1, then the L1 will be connected with L2, then this L2 will be connected with L3. Okay, so let's say we'll prepare the T average time for this also. The T average time for this also. So what will be the T average time? Now, if you remember the two-level organization concept, the T average time which we have used, in that case, what happens? First, it will be searched in the L1. First, it will be the data which we are searching. First, it will be searched into the L1. So what the heat, if the data is found in the L1, then what will be the heat ratio? The heat ratio is H1 and the average access time will be the T1. Let's say the data we have already found. Then in that case, we will do that. Now, in the next case, what will happen? What will happen in the next case? 1 minus, anyone? 1 minus
H1.
1 minus H1. Then the data that is, if it is not found in L1, then where we will find the data, let's say it is found in L2, then what will be the thing, 1 minus H1, after that
S2 T2.
no, not T2, because if you remember, we have said in the two-level organization, what happens in that case, because if it will be T2 in the case of the independent organization, but for this hierarchical organization, the data is searching in parallelly for the independent organization, but in this hierarchical organization, the data we have searched in using serially. So first the data we searched into the L1. So for that reason, we have already taken the T1 access time, because we first the CPU searched into the L1. So for the searching into the L1, CPU already take T1 time. So already it is taking the T1 time, and after that time wastage, CPU found that the data is not present in the L1. So it started searching into the L2 again, and in this L2, it has found the data. So that means we have to consider this searching time also. So because after searching this time, after doing the wastage or searching this time, CPU came to the conclusion that the data is not present into the L1. So it moved searching into the L2 again. So that means what we have to do? We have to consider this time also, T1 plus T2. This will be the case of the second. And what will be the third case? By seeing this, you say, try that what will be the third case?
1 minus H1, 1 minus H2, S3, T1 plus T2 plus T3.
H3, I have said, na, H3 we didn't have to consider, because in that case,
Yes, sir, yes,
surely
sir.
1 minus H1 minus H2.
then T1 plus T2 plus T3. This will be the thing, that 1 minus H1 then 1 minus H2 then T1 plus T2 plus T3. So total 3 times it will take. So this will be the thing, that T1 plus T2 plus T3. So this will be for our 3-level organization. So that's how sometimes it is given to prepare the T average time. So you will draw this picture, and after drawing this picture, do that concept, use this concept, and using this concept, you will prepare this formula from there. No need to remember this formula. No need to remember, because if you try to remember it, you will forget. So by this conceptual thing, you should remember. If you use this conceptual thing, then it will be clear to you. Because if it is clear, then it is not necessary to remember the all formulas, because it is not a possible to remember all the things. So step by step, like this, you will prepare that. You will prepare that. Then by seeing this, you will understand also, and you will prepare the formula by using this. Okay. Now we will discuss sometimes mathematics also given from there. So we'll discuss that mathematics example. Now let's say it is written, consider a system with the 2 levels caches. It is said consider a system with two level caches, access time of L1 and L2 and a main memory are 1 nanosecond, 10 nanosecond and 500 nanosecond. Hit ratio of L1 and L2 are 0.8 and 0.9. What is the average access time of the system, ignoring the search time within cache? Now, here it is mentioned, always read the very carefully, always read like this. If our mathematics should given, try to read the statement, what it says. Now here it is saying that consider a system with two level caches and access time of L1, L2 and the main memory are 1 nanosecond, 10 nanosecond, 500 nanosecond. That means it is saying what? You should use two level cache. That means two caches should be present and also a main memory should be present. That means what concept you have to use? Because here it is saying that two level caches, that means two caches are present and here it is mentioned the main memory. So that means how? Three devices are present. So that means we have to use the three level memory organization. So in this three level memory organization, we know there is independent organization and another one is the hierarchical organization. So we have prepared that. Now, what you have to read? It is saying that what is the average access time of a system ignoring search time within cache. Now, which organization you have to choose? You have to decide by saying that. It is saying that what is the average access time of system ignoring the search time within the cache. Then anyone?
Parallel,
Yes. Why you choose parallel?
because we are ignoring such time result, that is T1 plus T2, we do not have to add.
Yes. Because if we choose our this concept, this hierarchical organization, then this access time, let's say the data that is not found in the L1, then that means what? The access time, this access time we have to search. This T1 access time, after searching the T1 access time, CPU will say, yes, the data which we are searching, that data is not found in this particular device. So this is the wastage, na? This is the wastage. So you have to search, and after searching, wasting this time, you will go to the consideration that yes, we didn't found that data in the L1. But here it is saying what? Access time of the system ignoring search time within the cache. That means this search time, it is saying that ignore that. So where we can ignore? Because in this case, each and every device is parallelly searching. So that's why if we say, then this device search time, with this device we didn't consider. Let's say this device we cannot able to consider. We can do that. But in this case, we cannot do this. And one thing you should keep in mind that if any example, any like this, if it is given, always, that means if here it is mentioned that ignoring the search time within cache, in sometimes some examples or some mathematical, you will see that this type of statement it is not mentioned. Like this, any statement is not mentioned. Then how you can choose that? You can choose by seeing the, if anything is not mentioned in this problem, then always prefer to choose the this parallel organization, because this parallel organization, the time we get will be less compared to the hierarchical organization. So if nothing is mentioned in the problem, here it is directly mentioned, but there may be problem given that it is not mentioned anything. In that case, simply do what? Always prefer to do the operation using independent organization. Okay. So now we have already know that this here we have to use the independent organization. So we have to put this into the formula. So the particular formula we have to use. So you see in this using the particular formula, we have performed that this is the particular formula of the our problem, this independent organization, 3-level organization. The particular thing we have created this formula, that how we have created, I've already shown. So put the values here. So h1 value is what? H1 heat ratio will be what? Heat ratio, it is saying that L1 is 0.8. So 0.8. T1 is what? T1 is the 1 nanosecond. So 0.8 into 1 minus H1. So 1 minus 0.8. So what will be? That will be the 0.2. Then heat 2, that means heat ratio 2. What is the heat ratio of the L2 device? 0.9. So 0.9, and T2 is what? T2 is the time. So time is 10 nanosecond. So 10 nanosecond. 1 minus H1. So 1 minus 0.8. It will be 0.2. Then 1 minus H2 means 1 minus, what is this? 0.9. So 0.1. And T3 is what? T3 is the 5 nanosecond. So 5 nanosecond. So if we do this addition, then we will get the 12 nanosecond. So this option is right. So like this, the problem should be given. So these things you have to keep in mind. Okay. Clear to everyone?
Yes, sir.
Okay. So very less time is remaining. So in the next class, we will start the hardware control concept, hardware program control or control unit, or the micro program control unit. This is the 2-level and 3-level memory organization concept. Hope you understand. Then thank you everyone.
Thank you, sir.